Namaskar friends, welcome back to Mohanjanics. I hope all of you are safe and healthy and your studies also going well. As we are discussing basic signals in signal and system. In this lecture, we will discuss about sampling signal. This signal is very basic signal and most important one also as it is used to sample other signals. So be concentrate and watch this lecture till end so that your concept will be crystal clear. Before starting this lecture, I want all of you to attend this question and write your answer in the comment section below. I will give solution of this question at the end of this lecture. So without any delay, पढ़ाई शुरू करते हैं. Sampling signal. Sampling signal is similar to sinusoidal waveform. As we all know that sinusoidal waveform is like this. This is the sine function. It is like this. Its peak amplitude is +1 and its minimum amplitude is -1. So this is our sinc function or sinusoidal function. Now what we have to do, we just have to decrease its amplitude in positive t-axis as well as negative t-axis. So how it will become? It will become like this. It is similar to sinusoidal waveform, but its amplitude is decreasing in positive t-axis as well as negative t-axis. This is the sampling function. And how we represent it? We represent it by SAT. SAT. SA under bracket T. And its value is sine T by T. This is the formula for sampling signal. Now suppose if someone will ask you that what is the peak amplitude of sampling signal, then what you tell? See this signal, that sampling function has its peak amplitude at t is equal to 0. You can see this is the peak amplitude or maximum amplitude of the sampling signal. And what we have to do to get this value, just we have to put SA t is equal to 0 in this formula. Then how it will come? It will become as SA0 is equal to limit t tends to 0. Why I have written it? Because this formula has sine t by t. That means t is in the denominator. So that's why I have kept a limit. So limit t tends to 0 sine t by t, its value is 1. If you know the limits from mathematics, it will be clear to you. So as of now, you just know that limit t tends to 0 sine t by t value is 1. That's why its value is 1. Now if I will ask you that what are the values of this intersection point of this sampling function in t-axis, this point and this point. For this we have to find that for which value of t sampling t is 0. We can see that all these points sampling t value is 0. So what we have to do, we have to find points where sampling t is equal to 0. That means sine t by t is equal to 0. Okay, and as we know that for all these value t is not equal to 0. So that means sine t is equal to 0. If t will be equal to 0, then it will be undefined also. That's why I have kept here t is not equal to 0. Okay. This is for your additional information. Now we have to concentrate that for which value of t sine t is equal to 0. And we know that for sine n pi, n is the natural number from 1, 2, 3, 4, 5 to infinity, also in the negative axis also, that is -1, -2, -3. I will write here n is natural number. Okay. So for the first point, we have to put t is equal to, in place of n, 1. Then it will become pi. Second point will become 2 pi and 3 pi. Like this, it will go onwards. Okay. Similarly, it is in the negative t-axis, which will be minus pi, minus 2 pi, minus 3 pi, and minus 4 pi onwards. This will be the value of these points. This is the important concept. So be concentrate. Now, if I will ask you that what will be the value of this sampling signal at t is equal to infinity, this side or this side, then what we have to do at t is equal to infinity, that is sampling infinity, means limit t tends to infinity sin t by t. Now value of sin t for any t is between minus 1 and 1, and if we put t is equal to infinity, it will become any finite value divided by infinity is become as 0. That's why this sampling signal is going towards 0, positive t-axis and negative t-axis, both sides. That's why this signal is decreasing towards 0, or its peak amplitude is decreasing in nature, which drives us to our next question. I will ask you that whether this sampling signal is energy signal, power signal, or neither energy nor power signal. Although I have explained you all in my previous lecture, this is one of our topic. Now remember that topic, that any signal which is infinite duration signal, see that it is infinite duration signal, and if any signal whose peak amplitude is decreasing in nature, any signal which is infinite duration signal and its peak amplitude is decreasing in nature, which is like this, just our like sampling signal, then it is energy signal. Yes, it is our energy signal. Okay. Now let's go to our question which I have asked you in starting of our lecture, that what is the energy of this above signal, and as we know this is sampling signal only, and what will be the energy of sampling signal. So let's solve it. As we know that energy is equal to integration from minus infinity to plus infinity mod of xt square dt. This is the formula for energy of any signal. In this case, what is the xt? Xt is sampling t, which is equal to sin t by t square dt. Now I will not explain you the mathematical part of this integration. I am directly writing its answer or its solution. You can try it on your own. If you have any doubt, I will make a separate lecture for that. So as of for now, I am writing directly answer of this integration, which is pi. That means option A is the right answer. This is the end of this lecture. I hope all of you have understood it clearly. If yes, then don't forget to like this video, share among your friends, and if you have any doubt, any suggestions or any feedback, then write in the comment section below. And to be with me, subscribe to my channel. धन्यवाद दोस्तों, जय हिंद।